Hi, this is Paul from Foresight Tech. In this video, we are going to deal with the time for a linear model, which is to find the time the model needed to reach a desired value. This is the last objective for topic 3.1. Let's see the outline. First, I will introduce the formula for finding the time. Then we will practice two questions together about how to use the formula. Let's see the material. Here is the formula to find the time n. Let me draw a graph to show the question. Okay, like this. Suppose we have a model, a linear model. Let me give you the model is a increase model. Okay, so linear increase model. So here is the origin. And so this point is the initial, which is P0. We know the model. Let me give you an example, just the linear growth. And now we know the model. What the question? The question is like this. And sometime later, the model can reach to a desired value. If this value, we call it Pn. How long? Okay, the model needed to reach to this value. Can we find a time? Yes, we do. Can you see? If I draw horizontal line, and this point is the one we need, right? Where is the time? If we draw vertical. So here is the time. What is the time n? That's the question. Okay, so how to find the time n? Of course, let me highlight what we need. Because we know the model, so we know this formula, right? This is the explicit formula. Can you see now? And we need to find out what is the n. We need to know what is the slope, what is the initial, what is the future. Okay, and then solve this equation, and we can find out what the time n and that the model needed to reach the value. Let me highlight what is the final formula. The formula is here. Why we have this formula? Okay, super easy. Let me just show how to solve that linear equation. Okay, and I put the linear equation here is like Pm equals P0 plus n times d. Okay, so let me use the same d times m. They are the same, right? D times m. Okay, so now we need to solve. This is the explicit formula. We need to solve for n, right? Okay, so how to solve? First, we subtract the P0 to both sides. Okay, subtract the P0. See, what do we get? And we will get this. The right we can cancel, right? So the left we get this Pm minus P0 and equals d times m. Okay, now what do we do? Of course, we don't need a d, so divided by d to the right, divided by d to the left. Okay, then we can cancel this d. See, what do we get? We get the formula. Okay, so that's the formula we need. We get what? We get the n, the right side equals the left. So the left, if I draw it, is this Pm minus P0, right, over d. Can you see? Is this the formula? Yes, definitely. Okay, so this is the formula. I should at there, right? So at here, they are the same. And one more understand of this formula. Okay, so let me show you. If I wrote in this way, do you think it's the same? What is the right fraction? Okay, this fraction, if I wrote it in this way, what is the denominator d? D is just the slope, right? Can you see? What is the numerator? The numerator is the difference from P0 to Pn, which is the rise. Do you remember that? Is the rise, definitely. Okay. So what is the left side n? The left is run from 0 to n, right? If we show it from 0 to n, n minus 0, which is the round, right? So the left is exactly the round. Can you see? And this formula, they are exactly the same with this. And we need to find the time. The time exactly is the round. Okay, the round, of course, equals the rise over the slope. Because what? Because the slope equals the rise over the round. Okay, so this is one understanding. Now, let's go into practice 2 questions about how to use this formula. Here is the first question. Mario is interested in connecting Chinese stamp. Currently, he has connected 120 Chinese stamps. Each month, he connects 5 more stamps. See, connects the same number, which is a linear growth model, right? How many months does he need to connect the total 254? Okay, and then we know, okay, because the model goes up at this, okay, at this we know sometimes later, and the Mario definitely can reach 254 stamps, right? But we don't know how many months. And this exactly is going to find the time for a linear model. So what do we need to do? We just follow the formula. Okay, so let me directly copy the formula. So what do we need to do? N equals, okay, N equals, the formula give us is what? Is Pm minus P0, which is the rise over the slope D, right? And then we get the time, or we get the run. Can you see, plug in, this is the formula, and then we plug in. What is Pn? We're going to find Pn, which is the future value. Can you see? And this is Pn, right? The future. Okay, what is P0? Okay, so this number is P0, the initial. And what is D? And this number is D, right? So we have everything. I plug everything into the formula. So Pn is 254. P0 is 120. D is 5. And then do calculation. So we get a 134 over 5. And if we do calculation, we get a decimal number, 26.8. What does it mean? So how many months? And the question asks you the integer. Of course, it's 27, right? So can you see here should be 27 months. Therefore, 27 months we need. Okay, therefore the answer is B, right? Okay, so we have attention. I'll put it here. Attention. Okay. And these questions and the answer we get 26.8. And the point A, of course, do normal round, we can go to 27, no problem. However, if we do normal rounding for 26.1, okay, we should round down, right? However, this type of question is very special. We have to always round up. Let me write here. We always round up. What does it mean? See, and for example, if we get n is around 26.1 months, and we still need to choose, can you see? We still need to choose 27 months. Okay, why? Imagine why we need to do this. This is not always to normal rounding. Okay, because what? Because you can imagine 26.1 months, which means you need or Mario need more than 26 months, right? See, more than 26 months, which means what? Of course, it's 27 months. If you choose 26, and the Mario cannot reach to that number. Okay, so this is very special. So just pay attention. Of course, another case, if the questions ask you to round it to the nearest integer, which means what? To normal round. So you have to round this to 26. If the question did not show that round to the nearest, therefore you always round up. Okay, and this is the question. Then we're going to do one more question. Here is the second question. A town's population is 80,000 in 2019. The population has been growing by 800 people each year. Can you see? This is the common difference, which is a linear growth model, right? If it keeps growing linearly, in which year the population will reach or go beyond 90,000, definitely we can find a time, right? And the population reach or go beyond 90,000, definitely. So what do we do? And this question is similar as the last question. All we need is just follow the formula to find the time. Of course, just pay attention here. In which year, okay, is a little bit different from the last question. Let me copy the formula first. So here is the formula. We need to find the time n, or you say is the run. So is this Pn minus P0 over D, right? And the rise over the slope. Now we just do calculation. What is Pn? Let me find the Pn, the future value. Can you see this is a Pn, right? The future. What's P0? This is a P0, the initial. What's D? Of course, this is a D. We have everything, right? Now I plug in. So we have 90,000 the future minus 80,000. Of course, this is the run, the rise, right? And the slope D, the common difference is 800. And now what do we do calculation? How many? We get 10,000 rise over 800 increase each year. Therefore, we do calculation. This is easy to calculation, right? Divided by 100, divided by 100. Therefore, we have 100 divided by 8. 100 divided by 8 is 12.5, right? So 12.5 years. And therefore, always round up. So we have 13 years. Okay. So here is the one. But this is not the answer. See, the answer asks us in which year. Therefore, we have to add 13 years to the original 2019, right? Now do the calculations, easy. 2019 at 13 years, we get 2032, right? So this is the answer. Do we have an answer? 2032. Yes, we do. C is the answer. Okay, so that's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget, you are very welcome to subscribe to my channel for more videos. In the next video, let's see, we will move to exponential modeling. Hope to see you there. Thank you. Have a nice day. Bye.